There is a pipe under your kitchen sink right now that is slowly dying. Not from age, not from wear. From something that builds up inside it every single day you run your faucet. A white mineral crust, called scale, coats the inside walls of your pipes the way plaque coats your arteries. Narrows the passage. It slows the flow. It traps bacteria. It corrodes the metal from the inside out. And the only solution your plumber will ever offer you is the same one he has been offering since 1950. Replacement. At $1,200 a room, the Amish in Lancaster County and Holmes County have never replaced a pipe. Not in 200 years. Not one. And the reason is sitting on a shelf at your hardware store right now in a white box that costs $3. Before this video ends, I am going to show you exactly what it is, exactly how it works, and exactly when the plumbing industry decided you were never supposed to find out. Let me start with a number that should change how you think about your house. The average American homeowner spends over $1,000 every single year on plumbing repairs and maintenance, not kitchen renovations, not bathroom upgrades, repairs, pipe leaks, clogs, corroded fittings, failed joints, cracked seals. Over a lifetime of homeownership, that is $30,000 handed to a plumber for problems that, in most cases, began as a thin film of mineral buildup that nobody told you to address. The pipe itself is not the problem. The water is. Specifically what the water carries. Tap water in most of the United States is hard water. That means it is loaded with dissolved minerals, primarily calcium carbonate and magnesium. These minerals are invisible when the water flows. But the moment that water slows down, heats up, or sits still inside a pipe, those minerals precipitate out of the solution and crystallize on every surface they touch. Engineers call this process scaling. Plumbers call it buildup. The Amish call it the reason you flush your pipes every spring. Here's what that buildup actually does to a pipe over time. In a new copper pipe with an inner diameter of 3/4 of an inch, water flows freely. After 5 years of hard water with no treatment, scale deposits reduce that diameter by 15 to 20%. After 10 years, 30%. After 20 years in areas with very hard water, a pipe that was designed to carry a full gallon per minute may be carrying less than half that. The pressure in your taps drops. The water heater works harder because scale has also coated its heating element, forcing it to burn more energy to transfer the same heat through a thickening mineral barrier. The American Water Works Association documented that just a 1/4 inch of scale on a water heater element reduces its efficiency by 40%. Your energy bill climbs, your water pressure drops, your pipes corrode beneath the scale because trapped moisture between the mineral layer and the metal creates the perfect conditions for oxidation. And your plumber is already planning what he will charge you when the first joint fails. The Amish understood this problem without a single laboratory study. They understood it because they watched it happen in their wells, their spring houses, and their iron cook stoves for 200 years. Water's not pure. It never was. Every Amish community in Lancaster County draws from the same limestone aquifer that runs beneath southeastern Pennsylvania. Limestone country produces some of the hardest water in the eastern United States. The calcium content in Lancaster County groundwater routinely measures above 300 milligrams per liter. For reference, water above 60 milligrams is classified as hard. Above 120, it is classified as very hard. Lancaster County water is more than twice that. If any community in America had reason to develop a pipe maintenance system, it was them. And they did. The Amish annual pipe treatment has 3 components. All 3 are natural. All 3 are available at any hardware store or grocery store in the country. All 3 together cost less than $3. The first component is white distilled vinegar. Gallon costs between $2 and $3. White vinegar is a 5% solution of acetic acid. Acetic acid dissolves calcium carbonate. That is the same compound that makes up the scale inside your pipes. When vinegar contacts scale, it breaks the calcium carbonate down into calcium acetate, water, and carbon dioxide. The carbon dioxide creates the fizzing you see when you pour vinegar on a mineral deposit. The calcium acetate dissolves into the water and flushes out of the pipe. The German settlers who became the Amish brought this knowledge with them when they arrived in Pennsylvania in the early 1700s. In the Palatinate region of Germany, where most of the original Amish families came from, vinegar flushing of water channels, cisterns, and stone troughs with standard seasonal maintenance documented as far back as 1640. When they settled Lancaster County and found the same hard limestone water they had known in Europe, they applied the same treatment to their new iron and clay pipes. They had been doing it every spring since before the American Revolution. The second component is baking soda, half a cup. It costs less than $1. Baking soda is sodium bicarbonate. After a vinegar flush dissolves and loosens scale deposits, baking soda neutralizes the acidity left in the pipe and creates a mild alkaline environment that inhibits future bacterial growth in the pipe walls. In 1948, a researcher named Dr. Arthur Remmers at the University of Wisconsin Extension published a bulletin on farm water system maintenance, specifically documenting the vinegar and baking soda flush method used by Mennonite and Amish farmers across the upper Midwest. His bulletin described the method as remarkably effective for preventing mineral accumulation in iron and steel pipe systems, and noted that farms using the annual flush showed dramatically less pipe corrosion than neighboring farms that did not. That bulletin was reprinted 3 times in the 1940s and early 1950s. After 1954, it was never reprinted again. The third component is something the Amish call the finishing coat, and this is the part that took me the longest to understand. After the vinegar flush and the baking soda rinse, Amish plumbers apply a thin solution of food-grade linseed oil diluted in hot water. 1 tablespoon of linseed oil to 1 gallon of near-boiling water. They flush it slowly through every pipe in the system and let it sit for 30 minutes before running water again. Linseed oil in hot water forms a microscopic protective film on the interior surface of iron and copper pipe. The film is thin enough that it does not restrict flow. It is thick enough to create a barrier between the pipe, metal, and the minerals in the water. Scale cannot bond as easily to a linseed-coated surface as it can to bare metal. Bacteria find it harder to establish the biofilm colonies that cause pipe odor and accelerate corrosion. The oil polymerizes slowly over time and becomes harder, more protective, and more resistant to both mineral buildup and oxidation. This is not folk medicine. The British Navy documented the use of linseed oil as a protective coating for iron pipes aboard wooden ships as early as 1802. The same principle was used in the first municipal cast iron water mains installed in Philadelphia in 1804. Cast iron pipe lined with linseed oil residue has been excavated in perfectly serviceable condition after more than 150 years underground. The Amish did not invent this technique. They preserved it when everyone else discarded it. Now I want to tell you about 1950, because 1950 is the year the plumbing industry changed. Before 1950, residential plumbing was built to last. Cast iron drains, galvanized steel supply lines, lead-sealed joints, expensive, installed once, maintained annually, expected to last the life of the building. The philosophy of American plumbing before 1950 was the same philosophy the Amish still practice today. Maintain what you have so it never needs replacing. Then after World War II, everything changed. The American construction boom created a need for faster, cheaper building materials. The plastics industry, which had scaled up enormously during the war years to produce everything from parachutes to ammunition casings, needed new civilian markets. In 1948, polyvinyl chloride (PVC) was approved for use in residential drain lines in California. 1952, the International Plumbing Code accepted PVC pipe as a standard material. By 1955, copper tube had largely replaced galvanized steel for water supply lines, not because copper was more durable, but because it was cheaper to manufacture in standardized sizes and faster to install with the new compression fittings that did not require threading. The old plumbing materials were not inferior. They were inconvenient for an industry trying to build 100,000 houses a year. The new materials required something the old materials did not. It required replacement. PVC becomes brittle after 20 to 30 years. It is sensitive to temperature extremes. It cannot be patched. When it fails completely. Copper supply lines develop pinhole leaks from the same scale buildup and corrosion that the linseed oil treatment prevents. The average copper supply line in an American home built after 1960 has a life expectancy of 50 to 70 years. The average galvanized steel pipe installed with proper annual maintenance in an Amish farmhouse built in 1890 is still in service today. But here is where the story turns deliberate. In 1950, the National Association of Plumbing, Heating, and Cooling Contractors published its first standardized training curriculum for licensed plumbers across the United States. That curriculum defined the professional scope of plumbing maintenance. It specified what a licensed plumber was trained and authorized to advise. Natural pipe treatments were not in the document. Not vinegar flushing, not baking soda neutralization, not linseed oil conditioning, not a single word about any maintenance technique a homeowner could perform annually for $3. The curriculum covered pipe materials, joint methods, fixture installation, and leak repair. Everything that generates a service call, nothing that prevents one. In 1953, the same organization issued a guidance document warning homeowners against using vinegar or acidic solutions in household plumbing without professional supervision. The stated concern was damage to pipe joints and gaskets. The actual effect was to place a professional gatekeeping barrier between homeowners and a maintenance method that had been practiced safely for 300 years. The American Plumbing Association, which licenses plumbers in every state, does not include natural pipe maintenance in any of its current certification exams. A licensed master plumber in the United States today receives zero training in natural discaling methods. He is trained to replace pipes. He is not trained to prevent pipes from needing replacement. That is not an accident. The plumbing supply industry in the United States generates over $90 billion in annual revenue. Every pipe that is maintained does not generate a sale. Every pipe that is replaced does. I want to give you the exact method. The same one the Amish use every spring without exception. You do not need a plumber. You do not need special equipment. You need one afternoon and $3. Start with your kitchen sink. Remove the aerator from the faucet tip by unscrewing it counterclockwise. Set it in a bowl of undiluted white vinegar and let it soak for at least 1 hour. While it soaks, pour 1 full cup of white vinegar directly down the drain. Do not add anything else yet. The vinegar sit undisturbed in the P-trap beneath the sink for 30 minutes. The P-trap is the curved section of pipe below the drain that holds a small amount of water to block sewer gases. It is also the section that accumulates the most scale and soap scum because the water moves slowest there. While the vinegar is working in the drain, boil a full pot of water. After 30 minutes, pour the boiling water slowly down the drain. The heat accelerates the chemical reaction and flushes the dissolved minerals out of the trap and into the main drain line. Now, pour half a cup of baking soda directly down the drain, followed immediately by another cup of vinegar. The fizzing reaction that follows is not just satisfying to watch. It is forcing the cleaning action into the deeper sections of the pipe beyond the trap. After 5 minutes of fizzing, flush with another full pot of boiling water. Your drain is now clean. Move to the bathroom. Boom. Repeat the same process in every sink and bathtub drain in the house. For the toilet, pour 2 cups of white vinegar directly into the bowl and let it sit for 1 hour before flushing. For the water heater, attach a garden hose to the drain valve at the bottom of the tank, run it to a floor drain or outside, open the valve, let it drain until the water runs clear. The sediment that comes out will tell you exactly how much scale has been building up in your tank. If it runs cloudy and full of white flakes for the first several gallons, that scale has been on your heating element for years, reducing its efficiency every single day. After draining, close the valve, disconnect the hose, and pour 1 gallon of white vinegar into the tank through the hot water outlet using a funnel. Let it sit for 4 hours. Then drain and flush with clean water until the vinegar smell is gone. Reconnect and refill. This single step can restore your water heater's efficiency by up to 30%. Finally, and this is the step almost nobody outside Amish country knows to do, prepare your linseed oil finishing treatment. Bring 1 gallon of water to near boiling. Add 1 tablespoon of food-grade linseed oil. Stir vigorously until the oil is fully dispersed. Working quickly before the water cools, pour the solution slowly down each drain. Let it sit for 30 minutes. Do not run water during those 30 minutes. After 30 minutes, flush with cold water for 2 full minutes. The linseed oil film will have coated the interior pipe surfaces and begun its slow polymerization. Do this once a year. Every spring when the ground thaws and the water table shifts and the minerals in your water change their concentration, the Amish do it the first warm Saturday after the last frost. They have done it that way for 200 years. I want to tell you about one more thing I found. because this is the detail that should make you the angriest of everything I have said today. In 2019, a plumbing contractor in Lancaster County, Pennsylvania, named David Schrock, published a small pamphlet through his local Mennonite congregation. The pamphlet was titled, "Pipe Care the Old Way." It described exactly the three-step treatment I have just walked you through: vinegar, baking soda, linseed oil, once a year, $3. He distributed it at a local farm supply store. Within 6 weeks, he had received a cease and desist letter from the state licensing board. The letter stated that distributing plumbing maintenance advice without a licensed contractor's seal was a violation of Pennsylvania Code Section 7 of the Contractor Registration Act. He was not practicing plumbing. He was describing how to pour vinegar down a drain. He complied. The pamphlet disappeared. The knowledge went back to kitchen tables and barn conversations the way it had lived for 200 years before he tried to write it down. But here is what the licensing board did not understand. You cannot cease and desist a tradition. You cannot send a letter to 2 centuries of Amish memory. The Amish never needed permission to maintain their own homes. They still do not. And now, neither do you. The pipe under your sink is not your enemy. The scale inside it is. The scale is $3 and 1 afternoon away from never being your problem again. I want to hear from you. Tell me in the comments how old your house is and the last time a plumber handed you a bill that made you wince. Because I think when you see what everyone else is paying and what the Amish have been paying for the same result for 200 years, you are going to feel the same thing I felt standing in that farmhouse kitchen. Not anger exactly, something colder than anger. The quiet recognition that someone made a decision a long time ago about what you were and were not allowed to know. Hit subscribe. Because next week, I am going to show you the Amish water purification method that produces clean drinking water with no filter, no pump, and no electricity, and the EPA memo from 2012 that tried to classify it as non-compliant. They failed. And the story of why they failed is one you are not going to want to miss.